I'm a little nervous going through this video because this will be the first time that I've ever tried live on video working an Excel thermal systems problem starting from scratch. And so even instructors get nervous from time to time when they're not real experienced at doing certain things. And so sometimes instructors have something in common with students, get a little nervous. So let's go ahead and get started and see how it goes. What I want to do is go through a demo problem, solving a thermodynamics problem, a simple thermodynamics problem in Excel, and also utilizing the Steam Tables tool that I've reviewed as an intro in a previous video. So if you haven't watched that introductory video, I really recommend that you watch the Steam Tables intro video first. Also, this example problem is going to require that you understand the material up through chapter 3. In other words, you understand things about phase change substances, properties, and also you understand the difference between a closed system and open system, and you understand the basics of how and why you would use the first law of thermodynamics, also known as the energy balance. So here's the objective of this video. My objective is to demonstrate a step-by-step problem-solving technique for solving a thermal systems problem, trying to cover the basics of basic problem solving, whether you're using Excel or pencil and paper or MATLAB or Mathematica or whatever problem-solving platform you're using. And then I'm going to hopefully demonstrate how to utilize Excel Steam Tables and Excel for solving this thermal systems problem. So here's our problem. I've written it out, and I hope it looks a lot like a homework problem. A 0.2 cubic meter rigid vessel contains a saturated mixture of water and vapor. That's H2O, saturated mixture. The initial pressure of the saturated mixture is 155 kPa. The contents of that rigid vessel are heated until the mixture is transformed into a totally saturated vapor, only saturated vapor at 1100 kPa. And here's 3 questions in our problem. Determine the mass of the H2O contained in the vessel, the initial quality, and the heat added during the process. So before we jump into Excel, let's think about how will we solve this problem without thinking about the mechanics of how we'll solve the problem. Well, if you've worked with me at all, you're going to know that the first thing I say is, let's start with a sketch. We must start with a sketch. And so I've got a little screenshot of a sketch that I created. And I'll have to tell you that I created that sketch in Excel, and then I took a snapshot of it and pasted it in here. But you do see that it depicts what the problem statement said. I've tried to depict a rigid vessel. An initial state I'm showing as a mixture of vapor and liquid saturated at P1. I'm showing there's some heat going in, some work going out, a little more on that in a minute. And then the final state is totally saturated vapor. So I've tried to show that in a sketch. All right. So another thing we'd write down on our solution, whether we do it in Excel or pencil and paper or whatever platform we're using, the substance is H2O. It's a phase change substance. We're going to use the property tables. It is a closed system. Our problem is a closed system. That tells us that the mass inside the vessel is constant. We're going to draw a pressure volume diagram to visualize the process, and that is going to guide us. You may already thought, oh, I'm way ahead of you here. It's a rigid vessel. The volume does not change. It's a closed system. Let's see, the work done is the integral of P dV. And so since it's a rigid vessel, dV, even the incremental change in volume is 0. So since dV is 0, the integral of P dV is 0. So the work out is 0. We're just going to immediately write that down. Here's our pressure-specific volume diagram. And I created that in Excel as well, and I've taken a little screenshot to paste it here in the PowerPoint. But you see here that one thing you observe by drawing the PV diagram, instead of just having it in your head, now you visually see that the specific volume V2 at the final state is going to be V sub G. So that's going to be V sub G at P2. And now you're looking, okay, I think, let's see, I might get pressure table. I know a pressure. I'm going to look up V sub G at P2. That's going to help me along. Okay. I've got a and also V1 equals V2. The initial specific volume exactly equals the final specific volume. You visually see that with your PV diagram. All right, closed system. Since the volume stays constant, no work is done, just covered that. The final pressure and the phase is known. So V2 is VG2, see that on the PV diagram. And another thing to see is that since the mass is fixed and the volume is fixed, then you can determine the mass, M1 equals M2, just equals M. And let's see, I think I've got enough information given that I can determine the mass by V2, the volume given, divided by little v2, that's going to be V sub G at P2. So I think I see a path forward for getting the mass. The final specific volume equals the initial specific volume. So I'm going to be able to solve for quality using the definition that I know of quality. Okay, how will I do that? Well, let's see. I know V1. I know the initial pressure, P1. So I can look up VG and VF out of my saturation steam tables. And if I've got those, I remember the definition of quality. X1 is simply the quantity, the numerator, V1 minus VF1, there it is, divided by the denominator, VG minus VF. So it's a ratio. It's a ratio or a proportion. That's what the quality is all about. It'd be the initial, the mass of the vapor at state 1 divided by the total mass. Okay. And then finally, the third question was how much heat is added during this process described. We're going to use the first law or the energy balance. We'll write it out. Qn minus work out, which just showed that was 0. Qn equals capital U2 minus capital U1. That's going to be the mass that we're satisfied we can find times little u2 minus little u1. So I'm going to need to use steam tables to get little u2 and little u1. And here's how I'll do that. U1 is simply going to be the quality that we just found, X1 times VG plus what's left over, the remaining fraction, 1 minus X1 times VF1. So that's the way we'll get U1. And U2 is simply a lookup. It's going to be U sub G since it's saturated vapor at P2. So we haven't done anything with Excel yet, have we? Okay, but we're going to try to solve this whole thing in Excel. All right. So let's plan what we're going to do in Excel before I try to go live. Let me see what my green note is. So here's a roadmap. This is my roadmap to try to keep me straight and minimize my nervousness here. We're going to open the basic Excel steam tables tool because we need those tables and the formulas that I've created to get values for V and U, specific volume V and internal energy U. We're going to save as. We're going to take the basic file. We're going to save as with a different file name because we don't want to destroy our source document Excel file. The next thing we're going to do is a little thinking. We've done enough pre-thinking already. We're going to delete tabs that are not needed in our immediate problem solution to keep things simple in Excel so that if we share a solution with other people, they won't get confused. So we're going to delete unneeded tabs. We're going to try to remember to save frequently. I wish there were other folks on the call to remind me to save frequently. I'm going to try to have to remember on my own to save my file as I go along. How many times have you been working on files on your computer, whether it's Excel or PowerPoint, Word, MATLAB, any type of platform, and you forgot to file save? That's very frustrating, isn't it? All right, we're going to try to save frequently. All right, so we've deleted unneeded tabs. Then we're going to create new tabs where we're going to show our work. And in this case, we're going to create two new tabs. One's called Demo Problem. That'll be kind of like the introduction, the problem statement, the solution plan that's going to be coming out of here. And then a second tab will be our solution. Okay, two new tabs. We're going to create those and name those with these names to try to explain our work. We don't want to have just sheet 1, sheet 2. That's terrible. We're going to flesh out the intro tab with a sketch and a solution plan. And then that next tab called solution, we're going to work through the solution. We're going to work down the sheet. We're going to explain our work complete with units and hopefully come up with a nice solution that's easy to follow, easy for you to follow as you're reviewing your work and then maybe preparing for a quiz or a test, or share this work with others, or save it for a couple of years from now. And this type of problem might come up in your paying job, in your day job, and you can go back and look at the problem that you solved all the way back in Thermo. Okay, we're getting close to going live. How do you download the basic Excel file that you're going to start with and then save as? Go to Jay's Toolbox. Okay, go to Jay's Toolbox, drop down the Toolbox menu, go to XLS Docs. That's where I have a bunch of Excel files posted. Then you're going to fish through a number of categories. And this one, this particular file you're looking for is in XLS And so you're looking to download the file that I call StmTablesMoran. In other words, the numerical basis for this tool is Moran and Shapiro's textbook. Okay, it says go live. And so here we go. Let's give it a try. I've got this sheet. So I've tried to print out my little PowerPoint page. And this is my cheat sheet that's going to try to guide me through to survive here. Okay, and so I'm going to go to Excel. Okay, here I am in Excel, but I've got a blank Excel. I don't have any files open. Now, instead of downloading the file, I've already got this on my PC. I have downloaded my file. So I'm going to go to File, Open, and I'm in a folder that I know I can get to, what's called Live Demo. Okay, and I'm going to open StmTables, Moran, and Shapiro. Okay, and so hopefully you've seen, and there's a bunch of tabs here. Recognize that we're going to use. Let's click and see what we're going to use. We're going to use. Here's the data, but there's no Excel business here. This is just our raw data for a temperature table that we will use. And we're going to use the lookup tool for saturation properties, which uses the temperature table. And what we're going to do is we're going to copy and paste a big block of Excel cells. And as we solve our problem, that's a roadmap of what we're going to do. So let's see. Let me check to see what I've got. I've opened the file. Oh, save as. All right, so I'm going to come back to intro and I'm going to do file, save as, and I've told myself, I'm going to call this closed system demo live. Okay, here I go. Closed system demo live. I didn't put any spaces in there. I see it's going to the live demo folder, closed system demo live, save, boom. All right, now look at this. So now I've got a new Excel file. I can do anything I want to with it and not destroy my source document. So let's start deleting tabs that we do not need. Okay, I'm going to go all the way to the right. Let's say graphics. I don't need graphics for this problem. I'm going to delete it. I right-clicked on the tab and delete it. Superheated vapor. English, definitely don't need it. We're not in the superheated phase. Right-click, delete. Superheated English, delete. Right-click, delete. Pressure, English, no. Delete. We're in SI. Okay. I'm going to continue to scroll. Okay, let's see. Temperature, English, delete. Property lookups, English, delete. Superheat lookup, SI. Now we are SI, but this particular problem doesn't use superheated vapor. We'll delete this tab. Superheated SI, we don't need the raw data. Pressure SI. It turns out that our lookup tool does not require the pressure table. We're able to, the pressure table and the temperature table are numerically identical, and the way I've created the lookup tool uses the temperature table. So we're going to delete the pressure table. Property lookup SI, we need to save that. The learning tool, don't need. You've learned this already, okay? And then intro, we don't need this intro tab. We're going to delete it. Okay, so now we're down to 2 tabs. We've really simplified this closed system demo live. I'm going to come up here and hit File Save because we've made some progress. The next thing I want to do is create 2 new tabs. So I'm going to come over here and I'm going to click on this folder with the star on it, insert a worksheet, okay? And look at, and I'm going to drag it to the left. And sheet 1 is a terrible, terrible name for a tab, okay? And so I'm going to call it, this is going to be our sort of like our intro tab. I'm going to right click on it and I'm going to call it demo problem. And I don't leave spaces between my words when I'm naming tabs. And there's some reasons for this, subtle reasons we don't need to go into. I'm going to add another worksheet. I'm going to click on this. It calls sheet 2. I'm going to drag it to the left and I'm going to right click, rename it, and I'm going to call it that tab solution. Solution. And these are 2 blank tabs. So let's go to our demo problem and let's set that. And so if you see me do some work, we'll call this maybe, we'll title it system, closed system demo. We'll call it file, closed system demo live. By me on 5/28. Oh, crap. I clicked some key and I don't know what it did. Okay, and then let's see, I'm just going to make this a little bigger. Oh, I'm going to click on my whole sheet and make the font size 10 so that you can see it on the screen a little better. And in fact, on this A1 cell, I'm going to make it even bigger. I'm going to make that font size 12. Okay. So the next thing to do is we're going to type in the problem statement. And so what we could do is we could look at a piece of paper and type in a rigid vessel. We could just start typing. And so to minimize time, what I'm going to do is insert, I took a picture of the problem statement. I'm going to insert a picture, and my picture is prepared. It's a JPEG file, and I'm just going to paste it in here. And if I grab a corner, I can make it a little small. So there's my problem statement. Okay. Let's see. The next thing I do is I'm going to insert a sketch, I believe. So it would make sense to draw a sketch. And so let's enter another. So we've got a sketch. Now I created this initially over in a different file. So you can see it looks a lot like an Excel sheet, doesn't it? And so rather than investing the time to show you how to do this, to draw the vessel, I would insert a shape, and here's sort of a rounded rectangle, and then I can sort of draw that in and then make it pretty and add text and things like that. But you get the idea of how you could draw a sketch in PowerPoint or copy and paste a sketch that you prepared somewhere else, all right? So remember, what we're doing here is we're just reminding ourselves, what are we doing? What's the setup? Let's insert a pressure volume diagram. Okay, and so here's And so we're not doing any math here at all. We're just preparing. So here's our pressure volume diagram that communicates to ourselves what we're doing and to anybody else you're sharing this file with. And then finally, we're going to describe how we solve the problem. And so finally, to save time, let's see, I've got what I did. I actually typed this out in an Excel in a text box. But again, you see that if you're in a little more of a hurry, you can just start typing out in any cell, type out your work plan. Can't spell this morning, work plan. And then you can just keep adding whatever you want to do. But this is, you see that there's no math here. This is sort of a communication to folks. Here's my problem statement. Here's my sketch. Here's my PV diagram. And here's how I'm going to solve the problem. And this is just a review of what we talked about in PowerPoint. Okay, so the solution. I'll title that solution. I'm going to make this whole sheet size 10. Okay, so everything is font 10 on this. And another thing I'm going to do to keep myself on track, and I do this also in my work too, I'm going to copy this image from the demo problem tab. And I'm going to paste the image right here to this tab so that I can keep on track. And so let's see, I'm going to check the first thing. So we're ready to start solving this problem. The first thing we want to do is let's get some properties at state 1. So we'll say what we're going to do at state 1. Well, what do we need? And I'll make that bold. All right. Let's see. What's our initial we remember our approach. We're going to need the properties of G and F, saturated vapor, saturated liquid state 1, because it's going to be a mixture. We're going to need U values and V values, but all we know is the pressure. So what's our pressure? 155. So I'm just going to type in the number 155, turn it yellow and box it, and I'm going to label what it is. This is P1 units kPa. There we go. So that's the way I do my work. Is always, you type in a number. It's a number you type in, okay? But you say what it is and you have units. The next thing we do is we need our properties. How will we get our properties? Here's the important part of this video. We're gonna click on property lookup SI, and we are gonna grab a block of cells, not this block, because we're going to grab this block of cells because we want to have full Excel control of the pressure. And so I need to copy this whole block all the way out to column AK. So I've lit it up. I'm going to copy it into my clipboard. So all the text and formulas within this block are copied into my clipboard. I'm going to go back to solution. Oh, and it says here, these property lookup rows can be copied and pasted to any A column destination row. Just keep all the computations in a row together on the same row. So that's my little red warning, okay, of how to do this. Okay, so I've copied everything. I got to remember my destination has got to be in the A column somewhere. So I've got it in my clipboard. Back to solution. Okay, I can click anywhere in the A column and hit paste. Okay, boom, there it is. Okay, I've copied and pasted a block of Excel text and formulas. And now I need my properties. And so but I don't need it at 206. I need it at 155. Here's what I'm going to do. I'm going to create a very simple formula in cell B17 equals, and I'm going to click cell A13. Look at that. And all of a sudden, all my numbers are refreshed. Now, in my work, I didn't fat finger in that, did I? It's a little formula. And so in my world, I color that light blue. And that reminds me that I call it a transfer cell. Look how simple that equation is in Excel. It's simply equals A13. That's as simple a formula as you can get. But here's what I'm looking for. What am I looking for? I'm looking for VG and VF at 155 kPa. And no extra cost. I've learned that the temperature of state 1 is 112.12 degrees C, and my internal energy, UF and UG, is tabulated. So what I'm going to do is, to keep myself straight, I'm going to make those simple. I'm going to say equals this. Okay. And I'm going to call this VF1 meters cubed per kilogram. Meters cubed per kilogram. And how about the next, what we're going to do is VG1 meters cubed per kilogram. And then I'm going to skip a row and I'm going to have UF1 in kilojoules per kilogram. And UG1 in kilojoules per kilogram. Okay, so rather than sort of having them spread out, all right, so where's my formula? Equals, I've got to find VG, there it is. UF1, simple formula, equals, I'm going to find UF1, there it is. Simple formula, equals, in cell A23, equals, and I'm simply going to click on my UG cell, F17. And now just to clean this up, I'm going to box them and turn them blue because these are, in my world, transfer cells. But you see it now, I'm working down the page. I'm working down the page, okay? Now, let's go. We've got to get our properties at state 2. There's 2 ways to approach the copy and paste business. Oh, I know. Whoops. No. I need to enter my pressure at state 2, don't I? I'm going to copy and paste something I've already done here and then edit what I did. What is P2? It's 1100 kPa. And I better edit my label, P2. Great. Okay, now I've got 2 options. Now I need my properties. Remember, I need VG, the specific volume at state 2, and I need U sub G. That's going to be the internal energy of state 2 because state 2 is a saturated vapor, so I need less data there. I can either go back to property lookup SI and copy this block, or if I think about it, I say, look, I'm simply going to get the same formulas if I copy this block, and then I carefully say, okay, I got to be sure that this formula here points to this cell here. So I'm going to copy this block. Copy. Got to end up in the A column, okay? And I'm going to sort of skip a row just to spread out my work, and I'm going to hit paste. And I'm going to check my work. And look at this. So here's a formula that was copied and pasted, and Excel was so smart that it said, look, you copied and pasted a block of stuff, and I see that this formula is for 1, 2, 3, 4 rows up and 1 row over. And it's so smart that it did the same thing here. And so this formula that was copied and pasted is equals cell A27, which is exactly what we want. Okay. I'm not going to do the same copy and paste here because remember what do we need? We only need a couple of things here. We need V sub G. So I'm going to say equals this cell right here. And I'd better put it, this is V2 in meters cubed per kilogram equals VG2. Okay, that looks good. So I'm going to turn that blue. And then also, how about U2? U2 in kilojoules per kilogram equals UG2. And let's see, we've got my formula equals, and here's U sub G. Now, see how I do a lot of writing or typing of text and explanations in Excel. it really pays off for me rather than just having a bunch of formulas. Okay. So there's U2. We're working down the page. Okay. Next step, we need the mass. So I'm going to say work on the mass. Okay. And let's see, the mass, M is going to equal V2 over little v2. Okay. Well, okay, so let's see the mass. Where is V2? Well, we don't know what it is. We have to remind her, oh, it's 0.2 cubic meters. So I've got a fat finger in. 0.2 is the volume. I said mass, volume. V2 equals V1. And the units are meters cubed. Meters cubed. And I better turn that yellow because I just fat fingered in the number 0.2. Now, how about little v2? Cubic meters per kilogram. And from above. Because, look, we've already got V2, don't we? And so it's kind of a courtesy. I'm just going to click on this cell right here because there it is staring us in the face. Could turn it blue. I'm just going to, well, we could turn it blue so it is sort of a transfer cell. Okay. And now we can calculate the mass. Mass is going to be kilograms equals V2 over little v2. And now we can create our formula. The mass, V2, there it is right there, divided by little v2. I don't have to go up through my work to fish it out. There it is staring me in the face. And so there is our mass, and let's make it pretty. That's way too many significant figures. So let's go to the number format, numbers, and let's make it, let's call it 3 decimal places to the right. So 1.114 kilograms, that feels a little better, doesn't it? Okay, what's the next thing we do? And so we might even put a box. I might put a little box around an outside border. There's the mass. The next is work on the quality at state 1. That's X1. And what is that going to equal? Let's see. That's going to be equal to V1 minus VF1. We can go back and look at our approach, but we should be able to remember this in our minds. VG1 minus VF1. Okay, and so I'm going to turn that bold because that's what we're working on. And let's see, let's transfer our V1. Well, V1 is V2. V1 equals V2 cubic meters per kilogram from above. There it is. Okay, let's see, VF1. There it is right there. About VG1. And let's see, I can grab, this is just text that I typed out, so I can grab that and put that there. I could type in the words from above. Okay. And now I can do it now, X1. All I have is a pretty simple formula. And look, the numbers in Excel they're sort of sitting out there for me. So it's easy to create my formula equals the numerator, the parentheses. Let's see, it's V1 minus VF1, close parentheses, divided by the denominator, parentheses, VG1 minus VF1. So there is the quality. And let's put numbers. Let's make that about, let's say 4 points to the right. Make it nice. Okay. And in fact, let me show you a little trick here in Excel. Another simple formula equals that, equals the cell above. Let's change the number format. Number, instead of numerical number, let's change it to a percentage. And let's say 3 decimal places to the right. Okay. So it's 15.63%. Let's make it 2 decimals to the right. Makes it look better. Same thing, X1. So those are identical numbers. Look at the formula, A48. So we created we determined X1 numerically in cell A48, and we just, in A49, we made it a little more visually appealing. Okay, so that is our quality at state 1. The next part of the job, we're getting near the end. How much heat was added? So we're going to apply the first law. Use first law for closed system for Qn. I'm going to make another W out equals 0 since dV equals 0 for the closed system. Okay, and I'll make that bold. All right. And so let's see, what do we need for the first law? Maybe we could write it out. Qn minus W out, which is 0, equals U2 minus U1. I'm just typing text here, and that's going to equal the mass times little U2 minus little U1. So let's see, U2 I see up here. Got it. Let's see, U1 we need and we don't have yet. So let's calculate it. U1 kilojoules per kilogram. And how will we calculate that? We're just typing text here. That's going to be equal to X1 times UG1 plus the quantity 1 minus X1 times UF1. That's the way we get U1, right straight out of your book. Should be in your head, I hope. So now we can do our formula. Equals, okay, X1. So here's X1 times, it's going to be UG1. Notice I didn't transfer, and so I'm having a much more tough time creating my formula. But I'm gonna continue to blunder ahead. You do see that it would be much easier to transfer all the numbers down. Okay. Plus, what's left? 1 minus X1. Here's X1. Times UF1. So look how clunky I'm doing here. So I am dragging. So I'm doing okay because I'm fishing through, I'm working up and down the page, looking for the correct variables. Okay, I'm done with my formula. I'm going to hit enter. Okay, and there is my U. But this was a clunky demonstration that if I had made it easier on myself by transferring some of those numbers down, I would have had a lot easier time creating my formula for U1. So again, let's make this number, let's say 2 decimal places to make it pretty. Okay, so there's U1. Let's pull down U2 from above. So I'm going to, a very simple formula here is, where's U2? Here it is. So there is U2 in kilojoules per kilogram from above. And how about the mass? Let's do the same thing, mass, kilograms from above. Because this is probably the way you think about things in your head anyway. So now we have everything we need to determine Qn in kilojoules. We'll just look at our work. Equals our formula, the mass, times the quantity, U2 minus U1. So we'll click on U2, A56, minus U1, A55. And there is our numerical result. We need to make it pretty. So wow, we've got plenty of figures to the left of the decimal. So let's just make 1. Okay, and so here's Qn, and we can box this out. We'll do a little outside border thing to show our work. Okay, and so there's Qn, and we have solved the problem in Excel. And so I'm going to make this bold. Okay, well, 12. And so as I scroll up and down in the sort of the solution sheet, sort of get a little vision of what we did. Oh, and I didn't think about saving often. So I haven't done file save for a long time. I had better save my file. Good golly. I would hate to lose all of this work. Whew. So anyway, what did we do? We started at state one and we fat fingered in the given pressure. We copied and pasted a block of Excel formulas and text complete with units, formulas, in order to extract the thermodynamic properties we needed. Okay. Did the same thing for state two. All we needed was VG and U sub G from that state two. Then we reminded ourselves of our solution approach. We worked on the mass, then we worked on the quality, and then we worked on the first law. And did you see kind of how boxing these out really helps make the work pop out at you? And the other thing I would say as I'm blundering through this video, these techniques of boxing your work, working down the page, it's not just for Excel. That should be the habit that you develop even when you're working on pencil and paper, when you're working in MATLAB or Mathematica or whatever, and explaining your work complete with units. And so I hope there's file save again. So there's file save. I can close this file out, and I'm done with my homework problem. So let's go back to Excel. Let's go back to PowerPoint and review the finished product a little bit, sort of in slides. And so that you saw what we did was created a tab called Demo Problem, and we pasted in the problem statement, sketches, PV diagram. You could create those all in Excel as well, that's what I do in my problem solving. Some things that clearly documented problem being solved. Started with a sketch, and we outlined a solution approach in text, in almost like a little narrative. Then we went to the solution tab, okay? And so we started with state one. We determined the properties at state one. You can say this is from previous work that I've posted. You can get a copy of this out on my website to see how I really did it. We then looked at state two and then went on and on to solve the problem. Let's see. What else did we do? Here for this particular solution, I didn't box out my work, but you can see it. So it's a little tougher to follow, but at least in PowerPoint, I have shown it in red. Units are stated throughout the solution. I worked down the sheet, and the numerical results are clearly identified. And so at least I did this by boxing these out in red in PowerPoint, but in the Excel environment, I sort of boxed them out in an outline box. Okay. So this is important to recognize in any engineering problem solving. Units are stated throughout, work down the page. That maximizes partial credit if you get off track. You explain your work in text, okay, and numerical results clearly identified. So what are the takeaways from this live demo? I feel a little better now that I've been through it. But we started by saving as. We started with our source Excel file that we used for the Steam Tables tool. We did save as, so we didn't have to create things from scratch, okay? We created and named planned tabs and fleshed those out. We started with a sketch, even in Excel, and then we implemented the solution working down the sheet, explaining the work in text and units, and very important to include units. So I hope that gives you a little demo of of two things. How do you use that Steam Tables tool to speed up your thermodynamic property evaluation of H2O? And then also, how would you go about solving a thermal systems problem in the Excel environment? So remember, Excel is not the way to solve it. Pencil and paper works great. It's certainly going to be the way in your quizzes and tests that you solve and demonstrate your performance in this class. So you've got to get good at that. But you could also use MATLAB as a engineering problem solving platform as well. So I hope that helps, and stay tuned for the next video where I work out a steady state, steady flow open systems problem. Hope to see you then.